Use the identities in the text to find the number. There's no identity. Sine repeats every 2 pi revolutions. So picture, and I've been drawing this kind of, again, I told you if I don't have questions from you, I kind of assume things without, because it's like someone trying to show someone else how to dribble without not knowing, what their background is. If you know how to dribble really well, it's really hard to explain to someone else how to dribble. You just skip some steps probably. So just ask me questions if you feel I've left a gap out. I'm very likely to do that. So there's no identity. It just repeats after 2 pi revolutions. That means that if there's a particle going around the unit circle, it's going to come back to itself in a 2 pi angle every time it goes around like this. So sine of where you started is the same thing if you rotate it around 2 pi more, because you end up right back to where you started. But this answer is the same thing as adding 2 pi again, right? You just go back to where you started. And that answer is the same as that. No matter how many times you add 2 pi, you just get back to where you started. So if I added 2 pi 3 times like that, I'm going to get back to where I started. So the answer is that sine of t plus 6 pi just gets me back to where I started. So every even revolution of pi is going to get me back to where I started. So what's the answer? It's exactly where I started. So sine of t was 7 over 13. Sine of t plus 6 pi is also going to be 7 over 13. Nothing changes.
So it doesn't matter what number's in there?
It doesn't matter what number's in there. And sometimes I get an idea after I do the problem. So I'm going to show you with the circle why that's true. So what if instead you had sine of t plus 5 pi, not sine of t plus 2 pi? Well, do revolutions of pi. Pi is 90 degrees. So start where you are and rotate 90 degrees. It takes you to the other side, the antipodal or whatever. It's whatever you are here, it's the negative y value over here. And then whatever you had here, it's a negative x value of whatever you started. So the cosines and sines are negatives of where the cosine is going to be, okay, hold off. Let's go 5 pi. So that's negative 7 over 13. If I go back here, revolve back here, then I'm back to where I started. So that's a revolution of 2 pi, because I did pi and then pi again. That's 2 pi. If I did it again, I would get 3 pi, and the answer is minus 7 over 13. If I did it again, that's a revolution of 4 pi. I'm back to where I started. So every even pi is going to land you back to where you started. Every odd value of pi is going to put you across from where you started.
So the numbers either going to be positive or negative depending on the pi?
It depends where you are, actually, right? Because if you started here and rotated here, you would start, yeah, it looks like you're going to always be, the y values are always looking like they're going to, every revolution of pi switch signs. Revolve 5 pi, we get minus 7 over 13. Can you see it? So if you forget any identity, you can just go with your pencil across the thing, revolve around it the exact number of times it tells you, and you'll know. So it landed on minus 7 over 13. All right. Here they give you, assume sine of t is 8/9, and they tell you that the angle is between 0 and pi over 2. Pi over 2 is a quarter way around the circle. It's 90 degrees. So it's right a quarter around the circle, so it's in that first quadrant. And it says use trigonomic identities to find the number. Well, the way I remember this is to look at sine of t not as being the y value on the unit circle, but to think of sine of t as a graph by itself. You know, when you're little and you picked the x's and got the y's and plotted the points, right? You can do that too, and you'll get a different looking graph. You get what's called the sine wave. Here's what you get. Your calculators will graph this, and everybody needs to have a graphing calculator by next week so that we can do this. I want to show you how to do this on your calculator, because these graphs that I make on the computer, you can have with a touch of your keypad on your calculator. So valuable. So this is what the sine curve looks like. And from this, I make an observation that if I have an angle and it's positive, like sine of pi over 4, then sine of minus pi over 4 is going to be exactly negative of whatever I had up there. So in other words, it's like I can pull that, oh, this should be a minus in here. I can pull that minus sign out. So minus sine of pi over 4 is sine of minus pi over 4. So the minus sign just comes out. So this should be a minus here, not a, it's left out. Okay, so I'm going to use that. Here's why I want to use that. I know this thing about the 2 pi revolution stuff. I know that. But the 2 pi is first. It's not supposed to be first. I want to see what it does when it's second, when I add to the angle. So I'm going to move the 2 pi second. But if I turn 2 minus 3 around, I get a negative of what I had before, right? So I really have these two things are the same. Just so you can see that filled in, minus t minus 2 pi is the same thing as minus t plus 2 pi. All I did is pull a minus sign out, or factored a minus sign out. And then, and that's the same thing as 2 pi minus t, right? I can put the 2 pi first and the minus t second. So from that, I get that I can pull that minus sign out from the observation that, you know, whatever the angle was in there before, it's going to be minus the angle, minus the sign value. So from that graph observation I just showed you. But if I revolve counterclockwise 2 pi, or I revolve clockwise 2 pi, it's the same thing. I end up where I started, right? It's still the same thing. I'm doing a full revolution. So these two things are equal because you're right back to where you started. So this equals this, which is minus 8 over 9. That's, by the way, what cosine looks like. Cosine is, it looks, instead of looking like y equals x, going like this, it looks like a big cap. So what's cool about the cosine is we can do a similar trick to do the cosine. They gave you sine as 4/5, and I'm going to use that graph in a second. And they want you to use an identity to find the tangent of 8 pi minus t. It's going to get a little noisy here in a second. Tan t is sine t divided by cosine t. So I'm going to use that. We already know sine 8 pi minus t by using the same tricks I just used in the previous slide. I could turn that around and pull out the minus sign, and going 8 revolutions, the same thing as going 2 pi revolution. It's the same exact thing because I'm going around an even number of times clockwise. So I get this. So I know what the sine of minus t minus this guy is. It's minus 4/5. So that's exactly the same as the previous problem. But I don't know cosine, so I have to solve for it using the Pythagorean theorem. This is what we call a multi-step problem, because it's taking two different things that you know and then put it together. Sine squared plus cosine squared equals 1. And so the missing thing is this guy. I did a problem like this earlier, right? And then you can solve for the x squared. So it's exactly the same work as I did earlier. It turns out that that's 4/5 squared over. I just wanted to show you the details. And you can solve for x, and I get a plus and minus. But between 0 and 2 pi over 2, the cosine is positive. It's the x value. So I only keep the positive, x equals 3/5. So now I have the sine and the cosine. One last observation. Cosine of negative angles are exactly the same thing as cosine of positive angles. That's because if I draw a horizontal line through, cosine of a negative value gives you exactly the same thing as cosine of the positive value. The same y values you get when you plug in the t's. So cosine of 8 pi minus t, it's the same thing as turning it around. There's no minus signs above, it's like they all went away. And you get, that's the same thing as cosine of t, because revolving around 8 pi times is the same thing. It's just going to get you back to where you started. So now what I know is sine is minus 4/5, cosine is 3/5, tangent is sine over cosine. you put it together, you get minus 4/3.